Hello again, guys. Welcome after a long time. In this lesson, we are starting on logarithms. Logarithms is the second part of the topic on exponents and logarithms. And in this topic, we will split this into two parts. And this is, in fact, the first part where we will be just introducing the idea of logarithms, all right? So the scope of what we will cover today is effectively the first part is an introduction, seeing how we can reason out what logarithms are based on what we already know about exponents. We will convert between exponential and logarithmic notation, and that's assuming once we've understood what that is. Then we'll evaluate logarithm. When you're given a logarithmic expression, how can you evaluate that both using a calculator and also algebraically? That is without the help of a calculator. We will then solve simple logarithmic equations to try and understand make use of the idea of switching between exponents and logarithms to help us solve simple logarithmic equations. Later, once we've introduced the laws of logarithms, we will see how to solve a little more complex logarithmic equations. All right? And so without wasting any additional time, let's get on with it. So from exponents to logarithms, let's understand what logarithms really are, okay? So we already know what the exponential notation is. So any number, n, can be expressed as another number to the power of another number, k. In this case, n, a, and k have to be real numbers, but more importantly, a has to be a number that is positive, so it has to be greater than 0. Okay, so a has to be greater than 0. This is another way of saying that the value of a has to be positive. It's never negative. Okay, so this is what we refer to as the exponential notation. For example, a number such as 64 may be expressed as 8 to the power of 2. All right, so in that case, that is the exponent or the power of 8. Okay, so this is exponential notation. 64, by the way, could also be expressed as 4 to the power of 3 or even 2 to the power of 6. But the power does not have to be an integer. It could be any other power. It could be a decimal number as well. All right, either way, this is what we refer to as the exponential notation. Now, when we express a number 64 as an exponential in the exponential form like this, the 64, of course, is called the number. The 2 there is referred to as the base of the exponential notation, and the 6 is referred to as the power, as we have already been referring to it, or it can be called the index. In some books, as we will see later, in algebra, we can also refer to it as the order. But the more common term that we use is, in fact, the exponent. So the 6 is called the exponent. In fact, it is called the exponent of 2. All right? So it's the exponent of the base 2. We say that the exponent is a designation for the base 2 there. Designation, which is to say it's like a call sign, okay? Jet fighter pilots usually have a call sign. So it's a special name that refer to that particular pilot. So in this case, the 6 is a designation or a call sign for 2. It does not belong to the 64, it belongs to 2, and we say that 6 is an exponent of the base 2. All right, so we can say 6 there is an exponent of. So I'm stressing of to indicate that it belongs to the base 2. All right, so it is when we are referring to that base that we say 6 is an exponent. Okay, so in the same way, if we express 64 as 4 to the power of 3, then 3 is the exponent of the base 4 that will result in a value of 64. 6 is the exponent of the base 2 that will result in a value or a number value of 64. Also, in the same way, we can say there that 2 is the exponent of the base 8 that will result in a value of 64, like that. This is important that we express, that we refer to the 2, the 3, and the 6 as properties or designations of the base. Okay? All right, we're going to use an analogy that I like to use in order to help students remember how to convert between exponential and logarithmic notation. Notice we have not yet introduced what logarithms are. We've merely been talking about exponents. So let's look at this analogy for Ali's family. Okay, so here is Ali's family relationship. Ali has got a sister and a father. All right, and we are also going to place Ali somewhere there, just above the position of the father. So Ali's designation or call sign changes depending on the subject, whether we are talking about the father or we are talking about the sister. So if we are referring to the father, we will say that Ali is the son of his father. So the term son or the name son is used in reference to Ali when we are talking about the father. So Ali is his father's son. But when we refer to the sister, Ali cannot be a son. So we would say Ali is the brother of his sister. Okay? So when we are talking about the father, we will refer to Ali as a son. But when we are talking about the sister, we will refer to Ali as a brother. Okay? So clearly Ali has a name. That is, he can be referred to as a son or he can be referred to as a brother. His name changes or his designation changes depending on who we are referring to. We can use this idea father. So this time I want to give the father a name and the sister also a name there. So the sister will be referred to as Aliyah and the father Abdul. So we can say that Ali is the son of Abdul. So when we are referring to Mr. Abdul, Ali is the son. When we are referring to the sister Aliyah, Ali is the brother. Okay? We can use this similar way of reasoning when we are referring to this number 3 here. Okay? So with respect to the base 4, 3 is called an exponent. So when we are referring to that base 4, 3 has the name exponent. So we say 3 is the exponent of 4. In the same way that Ali is the son of Abdul. Okay? But when we are referring to 64, we can no longer say that 3 is an exponent of 64. And this is where this name comes from. Okay? So in reference to the 64, we can say that 3 is actually the logarithm of 64. So the name logarithm is used in this sense, in the same way that Ali is related to the sister and to the father. The 3 there is related to the 64 as well as to the 4, and the relationship between 3 and 4 is referred to as exponent, and the relationship between 3 and the 64 is the logarithm. So we say 3 is the exponent of 4 for the number 64, while 3 is the logarithm of 64 when the base is 4. Now that is very important. Let's see how we can write this down. So if we are using words, we express 64 is 4 power 3 as, so in words we would say 3 is the, so in exponents we would say 3 is the exponent of 4 where for the number 64. But in logarithmic notation we would say 3 is the logarithm of 64 when the base is 4, like this. So we would write 3 is the logarithm of 64 in base 4. In other words, when the base is 4. Now mathematicians don't like writing, sentences like this. So instead we prefer to use mathematical notation or symbols. So therefore in symbols, how do we write this? We would say 3, so we would write 3 is means equal sign, so is equal to logarithm of 64. But I'm not going to write the whole logarithm because as mathematician we don't want to write too much. So we can shorten that and say instead of logarithm we'll use the first 3 letters, log and 4. So we can say 3 is the logarithm of 64 like that. but we also have to indicate the 4 because 3 is not the logarithm of 64 when the base is not 4. So we must indicate that the base is 4 here. So this base has also to be indicated. So we put it down there to imply that it is a base. Okay? So we read this as 3 is the logarithm of 64 when the base is 4. So this is how we express this sentence up there. Okay? I'm hoping this is making sense. So in the same way, so this is what we refer to as the logarithmic notation, but in a similar way we could also we remember that 64 could also be expressed as 2 to the power of 6, and that is called the exponential notation. So if we wanted to write this in logarithmic notation, we would say 6 equals the logarithm of 64 when the base is 2. So 6 is log of 64 when the base is 2. You can also say log to base 2 of 64 or log of 64 to base 2, like that. All right? We can also write, since 64 is also 8 squared, we can write that 2 is the logarithm of 64 when the base is 8, or in short, 2 is the log to base 8 of 64. All right? I'm hoping this is making sense. So in summary then, any number n can be expressed in terms of a and an index k, either exponentially or logarithmically. And the notations that we use are as shown. These two notations are equivalent. So they refer to the same number. It's just a way of expressing the number. All right, so the first one there is the index notation that we used in the previous topic, and this is referred to as the logarithmic notation, which we will be looking at in greater depth shortly. Okay, all right, let's move on. One of the things you want to know how to do very quickly is to rapidly switch back between exponential and logarithmic notation. So if you are given an expression, or if a number is expressed in exponential notation, you want to be to be able to switch that to logarithmic notation, and if a number is expressed in logarithmic notation, you want to be able to convert that quickly into exponential form. So you should be able to quickly change from logarithmic to exponential and vice versa, back and forth between the different forms of representation. And knowing this is key to really succeeding in this topic. Okay, so if you are to be able to handle this topic better in the future, the first step is for you to know how to switch between logarithmic and exponential forms of the expression. All right, here is an example of what I'm talking about. We are being asked to convert to logarithmic notation, which is to say that we have been given an expression in exponential form. Our job is to express this. 5 to the power of 2 is 25. We know that is true. Can we change this expression in logarithmic form? Okay, the second one there. 3 is 81, power 1 over 4. Some of you may not notice that this is true. Remember, 81 is the same as 3 to the power of 4. So 3 power 4, that power of 4 multiplies with a quarter and gives us 1. So it's actually 3. All right, and thirdly, we will also try to express a equals to p power k in logarithmic notation. So notice that in question A, the left-hand side has 5 to the power of 2. In question B and C, the exponent is on the right-hand side. So that should not confuse you. Okay, I've put that intentionally so that you're able to always zoom in or locate where the power is, and you will always start with that power. Okay, it doesn't matter whether it's on this side or it is on this on the left or the right-hand side. Okay, so how do we convert those three expressions or equations into in logarithmic notation? So all you have to remember is that the 2 there is an exponent of 5. Okay, it's an exponent of the base, and so because we are looking for logarithms, we must say 2 is the logarithm of the number on the other side of the equal sign. And so I can write this as 2 is the logarithm of 25 when the base is 5. Like that. We are done with that question. All right. Similarly, we can express, so always go to the index there or the exponent there, and we know it is the exponent of the base 81, but the logarithm of the number on the other side of it. So we can write here that a quarter, 1/4, is the logarithm of 3 when the base is 81, like that. Okay? And lastly, a is p to the power of k. We can also express that in logarithmic notation. Go to the power there, k. K is the exponent of p, but it is the logarithm of the number on the other side. So we can write that k is the logarithm of the number on the other side, which is a, when the base is p, like that. Okay? And this is how we can change from exponential notation to logarithmic notation. Let's see how we do the next one. I'm going to give you the next one. I want you to try, pause the video before you look at the solution that I will have given. So here is the next set of questions. This is example A2. Convert the following into logarithmic notation. So there is the first one, the second one, and the third one. Please pause the video and try it out, and let's see what you come up with. Assuming that you've done so, assuming that you've done this, let's see what you get. Well, so we locate the exponent there. It is a third, and a third is the exponent of 343. 343 is always the base, so a third is the exponent of 343, but a third is the logarithm of the number on the other side of the equal sign. So we can write here that 1/3 is the logarithm of 7 when the base is 343, like that. Similarly, when we come here, 1 is the logarithm of the 16 on the opposite side when the base is 16. So 1, we come here and say 1 is the logarithm of 16 when the base is 16, like that. All right, easy peasy. Come to the third one there. 0 is the logarithm of 1. So 0 is the logarithm of 1 when the base is b, like that. And we are done. Okay, let's move on. Okay, let's look at another example. Example B1. So now we want to do the opposite. We've changed from exponential notation to logarithmic notation. In this question now, you're being asked to change to exponential notation, which is to say that we have an expression in logarithmic notation. We need to change that to exponential notation. So the first one is there. Log to base 2 of 8 is 3. The second one is log to base of 5/7 of p equals q. So the base there is 5/7. Okay, so the base is always written below, just after log and below, like that. So you want to remember that the 2 is the base, right? The 5/7 is the base. So we have to say 2, the base 2, to the power of what was the exponent. If you remember correctly, that was the exponent of this base. So therefore we have to start with that base. So when we are changing from logarithm to exponential form, we start by looking at the base. So go to the base and we see 2 there. So we'll write that 2 to the power of 3 must be equal to 8. And we have changed from logarithmic notation to exponential notation. So this here is 8. Similarly, we go to the base here and we say 5/7. So 5/7 has to be 5/7 to the power of q. So I'm going to put that in bracket and say to the power of q must be equal to p, like that. And we have expressed b in exponential form. All right, so it's important that you can change from logarithmic notation to exponential notation, but also from exponential notation to logarithmic notation without hesitation, very, very rapidly like that. Okay, that means you will identify what the logarithm is, what the base is. All right, so in this form, this is the base. When we express in logarithmic notation, the base is the one below there like that. Okay, this is the exponent. And this is what was the logarithm, or what appears as exponent in the case of the exponential notation. Here are two other questions. Please try to convert to exponential notation, and let's see what you end up with. So you're given A there, and here is part B. Could you please change that, convert that from logarithmic to exponential notation? Pause the video and try it out, and let's see if your answer matches mine. Okay, assuming that you've done so, once again, we go to the base, and our base there is 17, so we'll write 17 to the power of 2 must be 283. So, for this question here, 17 to the power of 2 must be equal to 289, like that. All right, similarly, 12 to the power of 3 must be equal to x. So for B, you must write 12 to the power of 3 must be equal to x. We have changed from logarithmic notation to index or exponential notation. Okay, next. Example B3, convert to exponential notation. Please try that out. Okay, convert that as well into exponential notation. Once again, please remember, just pause the video and try it out before you move on. All right, so clearly this is going to give us, this is going to be y to the power of 0.5. So I can write here y to the power of 0.5 must be equal to x. Now power 0.5 also means power a half. This can be written as y power half, which is also the square root of y. So either way, whichever way you write it, it's all fine. So y power half is x, or the square root of y is x. We know this from our understanding of exponents. So writing that would be fine. Any of the forms, whether you write y power 0.5 is x, or y power half is x, or the square root of y is x, all that is fine. Okay? In the second one, we would write that 5, because it is the base, 5 to the power of negative 3 must be 1 over 25. So 5, let me write it here, 5 to the power of negative 3 must be equal to 1 over 125. And that is actually true, because this is 1 over 5 power 3, and 5 power 3 is 125. Right, let's move on. Let's see what's next for us. Evaluating logarithmic expressions. To evaluate logarithmic expression is to find the value of the logarithmic expression. Now we can find the value of a logarithmic expression using algebraic means, but we can also use a calculator. So I'm going to show how to do both. So what we mean, let's look at an example here. So the ability to switch between the exponential form and the logarithmic form enables us to evaluate logarithmic expressions as well as to solve logarithmic equations. So what do I mean by this? Let's start by evaluating logarithmic expressions. Here's example C1. Evaluate the log to base 2 of 16. So in other words, what's the value? How much is this? What is the value of this expression? Okay, what number does this expression represent? So if we're going to solve this algebraically, the first thing we want to do is to assume that the value of this is some number x. So the first thing, we let our log there, log to base 2 of 16. What about we let this be some number x? If we let that be the case, then the next thing is to convert from this logarithmic form into exponential notation. And if we do so, we know that this is going to be 2 to the power of x is 16. So 2 to the power of x is going to be 16. Now we know we can express 16 as 2 to the power of 4. Okay, we need to have the same base on both sides. We've done this in exponential equations. This becomes therefore 2 to the power of x equals 2 to the power of 4. And that tells me that x, if the bases are the same, then we can equate the exponents. So this means x is the same as 4. In other words, the value of log to base 2 of 16 is actually 4. Okay, so we say we have evaluated this logarithmic expression here. Okay, I hope that's clear. Let's see another one. Okay, so this is example C2 and says evaluate log to base 36 of 6. So once again, if you like, you can pause the video and see if you can already get it. But otherwise, once again, all we need to do is for temporarily let the value that we are trying to find, let the value of this expression be x. All right, so once again, let log to base 36 of 6 be some number x. Change from logarithmic notation to exponential notation, then 36 power x must be equal to 6. So 36 to the power of x must be equal to 6. And once again, what we want to do is to ensure that the exponents, the bases are the same. So this is base 6 and that's 36. So we need to change to the lowest base, which is 6. So 36 can be written as 6 squared. So I'm going to write there 6 squared, everything to the power of x, right? And that is the same as 6. 6 can be expressed as 6 power 1. If we open that bracket by law 3 of logarithms, the powers just multiply. So we have 6 to the power of 2x equals 6 to the power of 1. And now because the bases are equal, the exponents must be equal. So we can write 2x must be equal to 1, there like that. Divide both sides by 2 and we will end up with x being equal to a half. So we have found the value of the expression log to base 36 of 6. We have evaluated log to base 36 of 6 like that. Okay, I hope that's clear. Let's see another one. Okay, C3. Evaluate log to base 16 of 1 over 4. Pause the video and try that question out. All right, assuming you've done so, we do exactly the same thing as we've done before. If we let log to base 16 of 1 over 4, we let that be equal to x, then 16 power x must be equal to 1 over 4. Now 16, we can write 1 over 4. We can write both sides as base of 4. 16 can be written as 4 squared, everything power x. And 1 over 4 can be expressed as 4 power negative 1 from our laws of exponents. And again, from there we know that we can multiply the two powers. This is 4 power 2 power x, so we multiply those. So I can write this as 4 power 2x is equal to 4 power negative 1. And so 2x, since the bases are the same, the exponents must be the same. So x there must be equal to negative 1. And we can divide both sides by 2. And we have x is negative 1 over 2, like that. Okay? And that is our value of this expression here. All right, we have evaluated that expression. Okay, I think we can move on. The next thing I want us to look at is how to use the calculator to evaluate logarithmic expressions or logarithmic just like the one that we've done there. So let's see how we can use a calculator to do these calculations, to find the answers. All right. In my classes, I use the graphical display calculator that is referred to as the TI Inspire. If you use a different kind of calculator, provided it's a scientific calculator, it should be possible for you to use it to find the logarithm expression just like the ones we've done. Okay, so just in case, the example I'm using here will be based on the TI Inspire, but you could use the TI-84 or the Casio series and so on. All of them will work and still give you the right answer. Okay, so here is the keyboard of the TI Inspire. We'll not go into how you turn it on, which is there, and the menu will be there. The key parts that we are interested in are already available here. So here is a question we want to solve. Example C4 now. Evaluate log to base 7 of 8. Now if we tried this using algebraic method, we will end up with 7 to the power of x equals 8. And we would not be able to write, let me just write that down. If we tried algebraic method, we would be saying let log to base 7 of 8 be x, and then say 7 to the power of x is 8. And now there is no base that we cannot make the two bases common. All right, there is no number that we can nicely use to make the two bases the same. Okay, and for this reason, our method, algebraic method, does not work for 7 and 8, and so our best way forward would be to go and use the calculator. Okay, and so we want to use this calculator here to find the solution. All right, so how do we do that? It's of course very easy, and so the way we proceed here is quite simple. So you'll go to the calculator, and the first thing you want to do is to locate the control right there. Okay, so this is assuming you've already gone into the calculator window. So on the home menu, you go and pick up calculation. So you get the calculation window. All right, and now all we have to do is to click on control. So what we are looking for is the logarithm. So we want to evaluate logarithm of 78. The logarithm is found somewhere down there, just above the 10 to the power of x there. Now the way to reach that function is to start with control. So control and 10 power x will actually be giving us the function log there. So the first thing then is to click on that control, okay, followed by the 10 power x there. Okay, you're going to get this screen. All right, so that template is going to appear on the screen, and so your job is now to enter your 7 there and your 8 on the other position. Okay, so press your 7, enter your 7 and 8, and then go and press enter there again, and as soon as you press that enter, you get a screen like that. All right, so the value you've entered will appear. You can see it up there, the value that you've entered. Now there are two possibilities depending on how your calculator is set up. If your calculator is set up to give the exact value, you will get this value on top, which is 3 log to base 7 of 2. We refer to that as an exact value. There are some times when we are not interested in the decimal number, we just want a clean expression like that, and so that's how you would leave your answer. But if the answer is required as a whole number, or a number in terms of decimals, then a calculator can give you that. If your calculator is set to give you numbers as exact as the top one there, but you want your answer to be in decimals, then all you have to do is now go back again and click Control, just like before, and then click Enter. That gives you the option above, just above it, which is saying approximately. So it's giving you the value of the log to a certain number of decimal places. So if you do that, this is the answer you should get. I urge you to go and try using your calculator and check that you get the same answer as we have found there. Okay, so that's how we use the GDC, the graphical display calculator, to determine or to evaluate logarithms of numbers. Here's a second one that I want you to try. All right, evaluate log to the base 1.5. 3 over 2 is also 1.5. So log to the base 1.5 of 8. Okay? Pause the video and try it out. If you've got the right answer, if you've done this correctly, you should, if you've done it correctly using your graphical display calculator, you should end up with the log to base 3 over 2 of 8 as being approximately 5.12853, and that is only to 5 decimal places. Your calculator might have a float that gives you more than 5 decimal places. That is fine. But this is the answer to 5 decimal places. Okay? Let's move on. So we have learned how to evaluate logarithms or logarithmic expressions. Now we want to use the same thing to solve equations. Alright, so the ability to change between exponential notation and logarithmic notation also helps us solve logarithmic equations. Alright, so we will only do very simple log equations just so that you have an idea of what is going on here. We will solve more complicated or more stressful equations ahead after we have discussed the laws of logarithm, which will be in the next video. Okay, so here we go. D1 is saying solve the equation, and this is a very simple equation. Log to base 2 of x is 5. So normally when we say solve the equation, it means find the value of x that when we put here will mean the left hand side gives us the same result equal to 5. Right? What is the value of x so that log to base 2 of x is equal to 5? And the way to do this, once again, as you may have suspected, is to change from logarithmic notation back to index or exponential notation. So we write 2 to the power of 5 must be equal to x, just like that. 2 to the power of 5 is 32, and therefore the value of x must be 32. Right? Very, very simple. Just change from logarithmic notation into exponential notation, and that gives us the answer that we are looking for. Do we have another one? Here's a second one. Log to base x of 64 is 2. So once again, let's change that to exponent notation, and we'll write x to the power of 2 must be 64. So x to the power of 2 must be 64. Well, we know, therefore, x has to be the square root of 64. Now, the square root of 64 is plus or minus 8. Now, but if you remember our definition, we said a has to be a positive number. So that a there, the base there, a, cannot be a negative number. And for that reason, our value x has to be equal to positive 8. Okay? So that is how we say we have solved the logarithmic equation, a very simple logarithmic equation. Let's look at another one. D2 says solve the equation log to base 2x of 216 is equal to 3. Right? So this is effectively the same thing. We'll write so 2x is the base, so the base to the power of 3. Remember, the base is both 2 and x, so you have to keep them in bracket. So I'm going to write, because of that, I'll write 2x to the power of 3. So to the power of 3 must be equal to 216. If I open that bracket, remember the exponent there goes to both 2, is distributed to both the 2 and to the x. So I can write here 2 power 3 times x power 3 is 216, but 2 power 3 is 8, so we can write 8x power 3 is equal to 216. We can divide both sides, we want x, so we can divide both sides by 8, and that gives me x to the power of 3 is 216 over 8. 216 divided by 8. If you look at that, 8 goes into 21 2 times to give me 16. I'm left with 5 into 56. That gives me 7. So x to the power of 3 is 7. So x must be the cube root of 27. X has to be 3. Okay, and that is the answer that we get for this question. I hope this is clear. Looked a bit, just an extension of what we've done earlier, but it's effectively the same thing. Okay, I think I have a last one here. Solve the equation. Okay, actually this is the second last. Please pause the video and try to solve this logarithmic equation, and let's see what you get on the other side. Right? Pause the video and try it. So assuming you've done so, we are doing exactly the same thing. So 5 to the power of 1 must be equal to that bracket. So we can write here 5 to the power of 1 must be equal to 2x minus 1. 5 to the power of 5 is just 5, so I can write that as equal to 5, right? I've put it on this side, and so 2x must be equal to, I'll use a different color, so therefore 2x must be equal to, the 1, negative 1 comes to this side and we get 6, alright, divide both sides by 2 and we get x equals 3, and that is the value of x that we need to put there. Okay, so that log to base 5 of 5 equals 1. If we put 3 here, we get 6. 6 minus 1 is 5 in the bracket. So log to base 5 of 5 is equal to 1, like that, which is true, as we will see when we look at the laws of logarithms. All right, so that's how we solve that. I hope you got it right. Last but not least, let's see question number 4D4. Evaluate log to base x of 5x squared minus 36 equals 2. Please pause the video and try it out. We'll see what you get on the other side. So once again, we'll write this as x to the power of, so the base x to the power of 2 on the other side. So the base x to the power of 2 must be equal to 5x squared minus 36. Okay, I can move 36 to the other side. It becomes positive 36 equals 5x squared, and I bring the x squared to this side, minus x squared. That gives me 4x squared. So I can write, so this is 4x squared. So I can write 4x squared must be equal to 36. I can divide that by 4 on both sides and I get x squared is 9. So x has to be the square root of 9, which is positive or negative 3. But, so I'll write here positive and minus 3. But by rule, we know that the x there, the x which is here, cannot be negative. So we conclude that x has to be positive 3. Like that, and that is the value we have solved that particular logarithmic equation. I hope this has made sense, and I am putting up questions in the comment section. So if you want to try out questions like this, you can always go in and try them out. I will also share a website where I put up some questions, and you can always go in there and take a look and see if you can solve some of the problems there, right? And I believe that brings us to the end. This brings us to the end of this discussion. Before we stop, let's just recapture what it is that we have discussed in this lesson, part 1 of the discussion on logarithms. All right, so for a recap, what were we doing today? We have shown that an exponent can also be referred to as a logarithm. So it is an exponent, so the k there is an exponent if we are referring to a there, which is the base, but the k is called a logarithm if we are referring to the n. Okay, so an exponent, the name exponent can also be replaced by the name logarithm depending on what we are referring to. Okay, the second thing we've looked at is how to convert from exponential to logarithmic notation and vice versa. And as I've said, the task that you have to work on now is to try and be sure you can change between the two easily, right? So like I've said again, I have placed examples or questions on the comment section that you can go and play around with to be sure that you can interchange, you can change from one to the other without any difficulty. Okay, number 3, so that is of course the exponential notation, and that is the logarithmic notation, and we've said that these are all equivalent and you should be able to change from one to another. Okay, number C or number 3, we've shown how to evaluate a logarithmic expression either algebraically or by using a calculator. Okay, and lastly, we have also solved some logarithmic equations using this idea of changing from exponential to logarithmic notation. All right, and that then brings us to the end of this lesson. Please let me know if anything has been difficult. Go and look at sample questions in the comment section and see that you are able to answer them. I'm going to include solutions to those questions so you can check against them to see that you're getting it right. Okay, I will see you next in part 2 of this discussion, in which we will be looking at the laws of logarithm and then applying them to solve a little bit more complex logarithmic equations. Okay, thank you very much. I will see you in the next lesson.